Okay, now at this point, we have examined the binomial coefficient from many different directions. We've extracted key identities which allow us to write binomial coefficients in terms of different formulations. We discovered two fundamental properties, Pascal's triangle and the binomial theorem. It is now time to test your understanding of these concepts. So, let me give you now 3 problems, each of which involves the use of the binomial theorem. Examine each of them, see what the binomial theorem says about each of them, and discover 3 interesting, fascinating combinatorial identities. Pause the lecture, and when you're ready, restart. Now that you're back, let's start with the first problem. 1 plus 1 to the power n. Identify p with 1, q with 1 in the binomial expansion, in the binomial theorem. And when you do that, you get the following expression, a sum of binomial coefficients. But because 1 plus 1 is manifestly 2, that sum of binomial coefficients, n choose 0, plus n choose 1, plus n choose 2, and so forth, till n choose n, must be equal to 2 to the power n. Here is your first identity. Now let's look at the second identity. In this case, p is 1, q is minus 1. When you take powers of q, you will get a minus 1 to the power times q to the power. But negative 1 to our power is plus 1 when the power is even, and minus 1 when the power is odd. Now we get an alternating sum of binomial coefficients. But this alternating sum must in fact be 1 minus 1 to the power n, or 0 to the power n. In other words, this alternating sum must be identically 0, and we've discovered a new identity involving these coefficients. One last time, if you said p is 1/3 and q is 2/3, we end up with one more identity. But you can now see how a whole stable of identities is waiting for you to discover. Just plug in suitable values for p and q, and out comes an identity.